Hi, thanks for being here. My name is Dong Song. I'm a professor in computer science at UC Berkeley and also the founder at Oasis Labs. Today, I will talk about towards building a responsible data economy. As we all know, data is a key driver for modern economy and is a lifeblood for AI and machine learning. More and more data is being collected every day, and EU's estimates that a significant percentage of EU's GDP comes from value created from personalized data. And global data economy is growing exponentially every year. However, a lot of this data is sensitive, and handling the sensitive data has posed unprecedented challenges to both individuals and businesses. Individuals have lost control over how their data is used. Oftentimes, their data is being sold or misused without users' knowledge and awareness. And also, a lot of this data is being sold under the premise of anonymization. However, volume of research has shown that anonymization is insufficient to protect users' privacy. So here on the screen, you see the case study done by New York Times, who was able to track the location of a Secret Service agent with former President Trump from an anonymized mobile phone location dataset. Businesses continue to face challenges from large-scale data breaches. In many recent attacks, attackers were able to compromise and steal sensitive information about hundreds of millions of users, or even billions of users. And also, it's becoming more and more cumbersome and expensive for businesses to comply with the privacy regulations such as GDPR and CCPA. And most importantly, a lot of the valuable data is sitting in data silos. It's being locked up, not being able to be utilized due to privacy concerns. So today, all these big challenges are hindering societal progress in the digital era. And if these challenges are not addressed, they could undermine human values and fundamental rights in the future. And hence, we are facing an urgent need for a framework for a responsible data economy. What do I mean by a responsible data economy? What are the goals and principles for a responsible data economy? So first, we need to establish and enforce data rights. These data rights will form the foundation of a data economy to prevent misuse and abuse of data. We also want to ensure fair distribution of value created from data, such that users will be able to gain benefits from their data. And ultimately, we would like to enable efficient data use to maximize social welfare and economic efficiency, to help individuals, organizations, governments, and societies to best benefit from the valuable data. However, there are many unique challenges and complexity due to the particular nature of data. So first, there's natural tension between utility and privacy. On one hand, we want to extract as much value out of data as possible, but on the other hand, we want to protect the privacy of users' data, and hence there's natural tension between the two. And also, data has a very interesting property called non-rivalry, which is different from physical objects. Unlike a physical object, for example, a laptop, if I hold a laptop in my hand, nobody else can hold the same laptop at the same time. So this is called a rivalry property. However, for data is non-rivalry, meaning that if I hold a piece of data, somebody else could be holding a copy of the same piece of data. And hence, they could be utilized the same data as well at the same time. And because of the non-rivalry of data, there are many challenges dealing with data. So for example, once data is given out, once it's copied, then one cannot really take it back or undo this. And also data has property such as data dependency and data externality. For example, processed data can reveal information about the original data that it's computed from. And also data from one entity can reveal information about another entity. So all these unique properties of data pose unique challenges for handling data. And also, this means that we cannot simply copy concepts and methods in the analog and physical world to address the issues in the digital world. And thus, we need to build a new framework for a responsible data economy. And this requires a combination of technical and non-technical solutions. In particular, here, a framework for a responsible data economy has at least 3 components. One is the technical solutions to support responsible use of data. And we also need new incentive models to incentivize a responsible data economy. And we need a legal framework to provide the legal support. So first, let's look at the technical solutions. So first, traditional solutions are insufficient. Traditional solutions mainly utilize data encryption to protect data at rest or in transit. And in this case, then data is either not used, or if it's used, it's often copied. And as I mentioned earlier, once data is copied, then it's difficult for the data owner to maintain control of data and to control further usage of the data that has been copied. And also, as I mentioned earlier, anonymizing data is insufficient to protect data privacy. And thus, we need new technical solutions. In particular, we need to develop new technologies to provide data protection in use, not just at rest or in transit. To enable data protection in use, we need to address 2 main problems. First, we need to enable controlled use of data such that when data is being used, it does not need the data to be copied. And secondly, we need to protect the computation output from leaking sensitive information. To address these 2 main problems, in the research community and in industry, there has been rapid advancement in new technology development in the domain that I call responsible data technologies. And in this domain, here I talk about 4 different component technologies helping address different aspects of the issue of responsible data use. First, secure computing, including both hardware-based approaches as well as purely software-based approach utilizing cryptographic methods. And the goal of secure computing is to protect the computation process from leaking sensitive information about the data. And secondly, differential privacy helps protect the computation output from leaking sensitive information. And federated learning utilizes secure computing and differential privacy to enable data to remain at owners' devices and enable different entities to come together to train machine learning model in a distributed manner and hence protect data privacy. And distributed ledger can provide an immutable log for users' rights to data and policy for how data can be utilized. So let me just briefly talk about some of these component technologies and recent advancements. So first, let's look at secure computing. The goal of secure computing is to protect the computation process from leaking sensitive information. Again, as I mentioned, there are 2 main approaches utilizing secure hardware or purely cryptographic based approaches utilizing just software. With the cryptographic-based approaches, the challenge is that the performance overhead oftentimes can be orders of magnitude higher than native computation, and hence usually it's only for special purpose computation. In recent years, the performance of these cryptographic-based methods, including homomorphic encryption and secure multi-party computation, has improved dramatically. In certain cases, have improved by orders of magnitude. But however, still today, homomorphic encryption-based methods as well as secure multi-party computation-based methods are still too slow for many real-world applications, such as training machine learning model for example, for tasks such as ImageNet, image classification, and so on. And the other approach for secure computing is utilizing secure hardware. And the advantage of utilizing secure hardware is that the performance can be close to native computation, and thus it can support for general purpose computation. With the secure hardware, it essentially uses a combination of hardware and software mechanisms to enable isolated execution environments, often called secure enclave or trusted execution environments. We can run programs inside the secure enclave and have data decrypted inside the secure enclave, such that the outside applications and operating systems will not be able to see what's running inside the secure enclave, and also will not be able to modify what's running inside, and thus provide integrity and confidentiality of the computation and the data. And also secure hardware has a capability called remote attestation to enable the remote verifier to verify the correct program has been running inside the secure enclave with the right initial state. Secure enclave with its strong security capabilities can essentially serve as a cornerstone security primitive to enable a platform for building new security applications that couldn't be built otherwise for the same practical performance. And given its importance, over the years, different hardware manufacturers have developed different hardware solutions such as AMD SEV, SMP, and Intel SGX. However, these are all closed source solutions. At Berkeley, we also have been developing Keystone, which is the first open source framework for end-to-end development of customizable TEs and trusted secure execution environments. And Keystone is built on top of RISC-V, which is an open source RISC architecture, and enables modular and flexible design with minimum trusted computing base. And with our experimental results, it shows that Keystone has close to native performance for real-world benchmarks, such as machine learning benchmarks and so on. And you can run Keystone on latest RISC-V boards and in other settings as well. And Keystone is currently supported by the Confidential Computing Consortium as an open source project. So I strongly believe that in 10 years, secure computing will become commonplace. In 10 years, most chips will have secure enclave capabilities. And in 10 years, most computation will use secure enclaves. And in 10 years, hardware accelerators for cryptographic methods for secure computing will also be widely available. So that's the first component technology, secure computing, for protecting the computation process from leaking sensitive information. I also want to briefly talk about the second component technology, differential privacy, to help protect the computation output from leaking sensitive information. So to look at why this problem is important, so first let me share some results from our recent study in collaboration with the researchers from Google and other places. In this work, we set out to explore the question, do neural networks remember training data? And if yes, can attackers exploit this to automatically extract secrets in the original training data from just querying the learned models without even knowing the details of the learned models? So in this work, we study language models. Language models essentially are trained on a corpus of text, and when given a sequence of words or characters, the language model will predict the next word or character. In one of our case studies, we show that when we train a language model on the email dataset called the NRUN email dataset, the NRUN email dataset naturally contains actual users' credit card and social security numbers. And in this case, by devising new attacks, we show that an attacker can automatically extract the original user's credit card and social security numbers in the original training dataset, and hence illustrating that even as we train machine learning models, it's important for us to pay attention to protecting users' data privacy. And in our recent study, we also studied whether this phenomenon appears in large-scale language models such as GPT-2 as well. And by devising new attacks, we show that the same type of phenomena also occurs in these really large-scale language models too. So this is an example illustrating that by just querying GPT-2 without knowing the details of the GPT-2 model, we were able to automatically extract personally identifiable information included in the original training data. So how can we address this problem? In some cases, by training a differentially private machine learning model instead of a vanilla machine learning model, our work shows that one can still maintain good utility, and at the same time, we can significantly enhance the privacy protection for users' data. And also, in our recent work, we have developed new techniques to enable automatic program rewriting to automatically embed differential privacy mechanisms in data analytics queries, and also by building new linear type systems, we are able to automatically enforce differential privacy statically and provide provable privacy bounds for machine learning algorithms. And some of our technologies have been piloted in industry, including Uber and other places. So together, these component technologies help build a platform for a responsible data economy. And when we put them together, we can enable what I call decentralized data science with data commons. So in this case, different data owners and producers globally, they could contribute their data, register their data sets with metadata in data catalogs with policy specified how they want their data to be utilized. And data consumers, such as data analysts and machine learning researchers, can then search through the data catalogs globally to find relevant data. And the data consumers can then write the data analytics and machine learning programs utilizing the different data sets and data sources. And the platform supporting this decentralized data science can then provide distributed secure computing while ensuring the program is compliant with the desired policies. With such an approach, we can reduce friction of data usage, remove data silos, and provide strong security and privacy protections. I strongly believe that in 10 years, data trust and data commons will become predominant ways of utilizing diverse sources of data, enabling ownership economy where users benefit from their data as owners and partners. And in 10 years, data stewards, fiduciaries, and trustees will be a new class of entities important in the data ecosystem, managing and protecting users' data and growing its value. And in 10 years, huge economic value will be created through these new forms of data trust and data commons, orders of magnitude higher than today's data marketplace. And also, when we combine these privacy computing technologies with blockchains, we can even enable a new paradigm of what I call data assetization. Essentially, we can create a new type of assets that I call data assets, where blockchain can help provide an immutable log of users' data rights and users' policies of how the data should be utilized. And with privacy preserving computing technologies, it can help ensure data remains private during compute and cannot be reused without permission. And this capsule of data and policies together can create a new type of assets that I call data assets that enables data to be utilized in a privacy preserving way and helps data owners to maintain control of their data and benefit from their data. And also at OASIS Labs, we are building a platform towards this data tokenization and data assetization to enable a new responsible data economy where individuals can maintain their data rights and earn value from their data assets. And we have applied this in the domain of genomic data to help users to become owners of their genomic data and maintain control of their genomic data while their genomic data is being utilized in a privacy-preserving way. And to enable a framework for a responsible data economy, besides the technical solutions, we also need to enable new incentive models and legal framework. We need new incentive models to determine how to help us to determine and distribute value of data. And in this area, our recent work shows that we can model machine learning as a collisional game and utilizes Shapley value to provide a rigorous framework for distributing value to data contributors. And also from the legal framework side, we need to address the open challenge of what are data rights and who controls data rights. Individual property rights are a cornerstone of modern economy and has helped establish modern economics and fueled centuries of significant growth. And today, we lack an adequate framework for data rights. Establishing data rights will allow individuals to derive value from their data and propel economic growth and unlock new values. And overall, we need data-driven and technology-informed regulations. So for the future of the internet, we need to build a responsible data economy, combining technical solutions, new incentive models, and legal framework. And I would say that the 2020s is the decade for building a responsible data economy. Thank you.